All right, go gadget energy problems. Here we go. Scenario: 5 kilogram mass drop from a height of 3 meters onto a platform supported by a spring that has a spring constant. That seems so grammatically weird, but whatever. Has a spring constant of 700 newtons per meter. Determine the velocity of the mass upon impact. That is with the platform. Determine the maximum compression of the spring. So you got two things you have to do. So velocity upon impact, maximum compression of the spring. All right. Now, I want you to do your best. See what you can do. On your mark, get set, go. Pause the video because I'm going to give you the answer in like 2 seconds. Okay. All right. I'll give you the answer. You wanted it. You asked for it. Here's your answer. The velocity upon impact is... Velocity of mass upon impact is a whopping 7.67 meters per second. Now, the funny thing is, you could actually go back to say, hey, it's a problem, it's in free fall, I can do a kinematics equation. So if you didn't solve it with energy, you can solve with kinematics. But I'm going to show you how to solve it with energy, just because we're in the energy unit. So, first thing, I know you did this. I know that you did this, is you did a wonderful, what's behind the box? There it is. You did a fantastic LOL diagram. In this case, it was pretty straightforward, pretty easy, because you do your LOL diagram and you start with EG because it's off the ground. So if you're going to say there is EG, you have a zero line. All right, so let's call this point right here EG0. All right, so it's 3 meters above that point. So I'm going to say, hey, that's the lowest point it's going to reach in this case, because after that, I don't care. So you got EG to start with, because it's not moving, because it was dropped, so your initial velocity is 0. And then you have EK when it reaches the ground, because it's reaching its max speed. So now, once you have that, all you got to do is substitute in your problems, see where it takes you. So when you do that, you get... what's behind the box? You get this. And you could use the mass because it did give you the mass, but you don't have to use the mass because mass does cancel out in this situation. So write your equation. EG is mgh, EK is 1/2 mv squared. Sub in the numbers where they belong, solve for v, you get your answer. All right. But that's just the first one. All right, that was the first one. The second one, all right, you can check to see what the maximum compression of the spring was. Now, if you did this right, then you get a maximum compression of 0.72 meters. So if you did it right, that's your max compression. And go you. If you didn't get that right, let's see what we could have done. Any guess on the first step we could have taken? Guesses? That's right. A wonderful, beautiful LOL diagram. There it is. There's the LOL diagram. So at this point, you again have to choose your zero line. Now, since it's going to compress, I chose a different zero line. I didn't choose here. I chose here. Okay? That's a 3, not an E. So I chose there to be my zero line. Because it's going to compress so far, I don't know what this distance is, so I'm going to call this distance delta x. That's my compression. Okay? So that's my x. So now that I have my zero line, I can now evaluate things, and it starts off way up here with all gravitational. Again, I chose not to start here. I could have chosen here, I guess, if I wanted to, but then I've had gravitational plus kinetic, and I always like to simplify things. So if I go all the way from the start to here, then I have pure gravitational, because we have no kinetic energy, because the initial velocity is 0. And then by the time it comes to max compression, it's all elastic. It's not moving, and it's at what I'm calling 0. So we are at max compression. We have pure elastic energy. So now that I have EG plus E elastic, now I can write an equation for that. And I'm going to have you try it. Okay, I want to see what the equations you come up with before I show it to you. All right, so On your mark, get set, try to write your equation. All right, just write it out. Think about it. Well, here's what I did, in case you were just too impatient. Here's what I did. I did this. Ooh, did you do that too? Good. Okay. But what's h? Well, when you sub that in, h is actually this. So mass we know, g we know, but the height, it's 3 plus this delta x, 3 plus x, because that's the overall height. And then your compression is also this x. So we're going to have x show up twice. So now we got to do some fun, exciting stuff. But hey, you guys are the honors class. You get the easy problems. So if you want to solve this, you got to use the quadratic. Yay! You love the quadratic. You got that function in your calculator. Graph it, do a quadratic solver, whatever works for you. But that's how you solve it. Okay? Most important thing is that setup. Hey, if you get stuck up on the quadratic, then that's math, not physics, but you really should work on that, get that in the calculator. All right, hope that helped. Hope you learned a lot, and I will catch you on the next one. Bye-bye.